All right, in this video, we're going to look at Logstash filters. We're going to figure out how to process documents. First, we'll start by adding a new data source. We've looked at a temp file. We've looked at the console input. Now we're going to add an actual log file from a system that is running on the server. We're going to configure the Logstash pipeline for it, and we're going to run the Grok filter. So first, we need to make sure we have Apache's HTTP server running on our Linux machine. Oh, I was moving again. We need to make sure we have Apache HTTP running on our Linux machine. So we have to make sure it's installed by using yum install httpd. I already have it installed, so this will fail. No big deal. All right, now let me show you our config file for Logstash before I run anything with HTTPD. All right, so if we look at this Logstash pipeline configuration, we see our input is a file called access.log. This is a standard log file from Apache. So if I ls that, or let's cat that file now, and we'll see the file doesn't exist. Okay, great. So now I need to run my HTTP server. And it's running. So what if I cat that file again? Okay, the file is there, but it's empty. So let's make an HTTP request. HTTP localhost, and we'll say missing file. I know this isn't there. So then we'll make a root request, and we'll get a HTML. Hi, this is my HTML. HTML content is not what really matters, but now there's records in our access log. We take in our access log. So you'll see the first request was to the URL get. It was a get request to the missing file URL with a status code of 404, meaning that file was not found. Then the next one was a get to the root, a file 200. Request took 19 milliseconds. So you can see the user agent of curl in both of those requests. So if we run this Logstash pipeline, we can see we'll start the beginning file. When you run in a production environment, you won't run your pipeline from the beginning of the file all the time, most likely. You'll run it from the last point in the file that it knew about, which is the default value or the default behavior of this start position attribute. I overrode it to beginning just so we could see what happens. So if I run Logstash, with this initial pipeline. So again, we run it as sudo because it queues on disk in the user share Logstash path, whatever the Logstash home is set to. And I'm going to run it with this initial httpd.conf file, which is going to read lines from /var/log/httpd/access_log. That's the file it's going to read from. Now you notice that we did not, again, we didn't change anything about what index it goes to in Elasticsearch, so we know it'll still go to those Logstash indexes. So let's look at that data in Kibana. So we'll go to Kibana, we'll flip to our Discover tab. This is the same Kibana we've been using, and you can see, let's see, we run that query with the quick recent timestamp. Remember, in the last video we were outputting messages in this temp.dummy, and we drilled in, so it was a very specific time range. So here we'll say in the last 15 minutes, what have we seen? So we've seen 2 events like we saw in the log file, and I'll show you some fields. Oh, these fields are good. We'll take out index. We don't really care about that. We know it's always going to be a doc. We know it's always going to be a host. So we'll leave the path. And in this case, you'll see we have a message. So the message, like in the other video when we kind of used the console to write the message, it was just string. It was a text. It didn't really mean anything. So when I look at my Elasticsearch index, if I want to start building queries or dashboards or visualizations around this data, this message is not reportable. It doesn't mean a thing. This message will pretty much always be unique. Aggregations will mean nothing, and you can't drill and you can't find stuff. So the thing we're going to do here, since this is not like, it's not a JSON structure. If we had a JSON structure, then Logstash could automatically parse that and put it into the index as a document. That's one of the input codecs. You can say this is a JSON object, and it'll parse a JSON. If it fails, it'll dump it. But here, I'm going to teach you about the Grok filter, because the Grok filter is the one you can use for structured data, like consistently structured data. Imagine using a bunch of regular expressions to extract pieces of the data. So we can say the first bunch is going to be the client IP address. The next bunch is a timestamp. Then it's going to be the method, the HTTP method, the URL, the version, etc. So we really need to fix this. Groks are interesting because they're very close to regex. They are not quite regular expressions, but they're close. So we need to look at the data we have, and we need to figure out what chunks we can pull out of it. As we were looking at, so we finished, like the last one here is going to be our user agent. So there are, I don't know, 8-9 pieces of data in there that makes sense. I'll show you the Grok, and there are websites out there that can help you test this, because it's like a regular expression, and if you mess it up, you mess it up, and it won't work. So test the heck out of it when you build it. So if we go back to our Logstash config file, you'll see, our initial file had no filter, and it just dumped it to Elasticsearch. Well, let me show you the final Grok filter. So it's a little different. So what happens now, we'll go to the same file from the beginning. We'll use this Grok filter and it's a match. If it doesn't match this Grok pattern, then it's not going to work. So we can say, oh, look, we have an IP or host, and we're going to call it client IP. So it'll use some magic behind the scenes, and that's the best I can say, because it's not a regular expression. It's saying, if this data looks like an IP address or a host, then pull it out and call it client IP. Then the next one is the user. If it's an HTTP basic authentication user, pull it out, and it'll put it into the HTTP user. Then it's going to pull out the HTTP date. HTTP date is the standard date format that comes out of an Apache log file. Then it's going to pull a word out that is an action, the HTTP action. Then the HTTP request will be next. The HTTP version number. The data is the raw request, status code, number of bytes, the HTTP referrer, if there is one, and the HTTP user agent. So this Grok filter is pretty magical. Let's see what happens when we run it. After we see the output in Kibana, I'm going to show you that Grok line one more time to show you, now that you'll have the full context of getting the raw data to the output data. So let's do a couple more curls while we're here. Call it post Grok 1. Whoops, says dummy. I hit up too many times. 3. So now I have a couple of log files. Let's see real quick. And you'll see the new outputs, the post Grok 2, Grok 3. So we'll jump back to our Kibana window. And we'll update our search. And now we shall see, look on the left. We have more things down here than just message. Now, the post Grok, let's filter our time range so we just have those in here. They still have this message, but let's expand the last one. Now we have, where's my client IP address of 127.0.0.1? Pulled that out. So we have the raw line from the log file, but we also have the other data that we pulled out with that Grok statement. So we have our HTTP action of get. We have our referrer, which is this hyphen here. We did not have one. Our URL of post Grok, our status code of 404, no HTTP user. User agent is here, the curl-7.29.0, and the HTTP version of 1.1. all of that from the Grok line. So again, now let's go back and look at that Grok again. So again, it's using this message field and then using special tags, or basically the data type that we're looking for. And behind that is an implementation that can use regular expressions. It can use string matching of any sort. You can build your own custom code to make your own Grok field types, but it comes out of the box with a lot of them. Look up the documentation, you'll see a full list. So IP or host, user, HTTP user, HTTP date, HTTP action is a word, not space is HTTP request. It's all there. And here you can see these were in quotes. So you'll see it'll have a quote, but what it cares about is between the quotes. It'll pull out a data field for an HTTP referrer. So it's like a not quite a comma separated file, but it's a space delimited file where strings are in quotes. All right, so there are a million plugins for Logstash. Input plugins. I went down the list and picked out some you might care about. You'd care about Beats. We'll talk about that in the next video, why I have Beats as an input. CloudWatch is an AWS construct to do monitoring. The file you can watch from GitHub, Kafka, RabbitMQ, XMPP if you want to listen to some filter. You can alter the data. You can do CIDR matching, which is a networking thing. You can look for CSV files. You can pull out date fields you can pull out strings and make it a date. You can take an IP address and make it into GeoIP, which means you can look it up against a dictionary or a database that says, given this IP address, where in the world is it? And it'll append that data to your document. So it'll say it's in Southeast Asia or Canada or Midwest USA, something like that. And it'll give you, geocode, get as close to it as it can, closest city, state, etc. We went over the Grok filter to pull data out of structured yet undefined data. Then then outputs. Editor, I'll update this real quick and show it to you with the word output there, not input. You can output to a CSV file. You can output to Datadog. You can output to Elasticsearch, which we've done. You can output to another file. If you're pulling metrics or data you're going to look at over time, you can put it in Graphite, or you can send it out to IRC. And basically anything you see as an input can be as an output, or an output can be an input. Not always, but a lot of times. All right, so here we're going to talk about the Grok filter, and then I'm going to show you an example of it using those HTTP log files. So Grok is a way to parse arbitrary or unstructured text and structure it. And when I mean unstructured, I mean it's not XML, it's not JSON, it's not a CSV. Unstructured means it's still a standard, or a consistent, that's the right word. It's a consistent data format, typically used for log files. It'll be your log file from HTTP. It'll be your log file from any application server you're using, Java, JUnit, Log4j outputs. It's always going to have your class name. It's always going to have your timestamp, your log level. So here's an example, a quick example that could come out of a web server. You can do 192.168.10.400 as the client. It's an HTTP GET to FOUI.html with the number of bytes returned of 16,623 and the duration of 0.43 seconds. In an example, Grok, you'd pull out the IP, you'd pull out the word for the method, a URI path parameter for the request. This is pretty straightforward. When we start looking at HTTPD output, it's going to look something more like this. So the first line here is our HTTP configuration file. It says, I want this log format, where these are the predefined things within HTTPD logging. And then here's the example log file output. So I'm not going to overwhelm you with the Grok below, but that's what we're going to build, and I'm going to show you why we build that. All right, in our next video, we are going to have Logstash as a server. So Logstash used to be just the logging agent on a machine. But now, if you look at things like Beats, you can distribute a really lightweight way of reading log files and sending it to a centralized collector that is Logstash.